Alright, just like the first part of this lesson, we are going to start with a warm-up, and then we're going to go into the McGraw-Hill stuff because graphs are way more fun when they're interactive and me not hand drawing them. Go ahead and take about 5 minutes or so, read through these problems, complete them, draw your own graphs, and then come back and we'll go over them. Alright, question 1. For each bullseye that Lydia hit in an archery tournament, she earns 10 points. Complete the table that shows the number of points for 1, 2, 3, and 4 bullseyes. So let's change my pen color because black on black is no fun. Let's do green today. Alright, so for each bullseye, she earns 10 points. So we know for each means 1, every 1. And then she earns 10 points. So that tells me my unit rate is going to be 1 to 10. Now, how do I figure this out? Or 10 to 1. What do I have to multiply this number by to get to here? So what do I have to multiply 10 by to get to the next? It's how many bullseyes, so it's going to be 10 times 2. So it's not, which is 20. So then what do I multiply to get here to here? I'm going to multiply 10 by 3, which gives me 30, because I'm taking the number of points by how many bullseyes she gets. So to get to 4, to get to this number here, I have to take 10 times 4, which gives me 40. So we know our unit rate is 10 to 1. Our net constant of proportionality is going to be 10. That's that number that I multiply by. All right, the table shows the distance in feet that Caleb travels with each step he takes. Graph the relationship between the number of steps taken and the total distance that Caleb travels. So we have steps taken, 0, he's going to go 0 feet. 1 step is 3 feet, 2 steps is 6 feet, and 3 steps is 9 feet. All right, so the first thing we have to do is graph this. So I'm going to put our steps taken is going to be our x, and our distance is going to be y. So this isn't labeled. So steps taken and distance. So 0, 0 is right here. 1 step taken is right here, and 3 feet is right here. And my computer's being special. Right there. 2 steps taken and 6 feet is all the way up here. And 3 steps taken and 9 feet is right here. All right, so now I can draw a line to connect those. So there's my graph. All right, so now we have to figure out the ordered pair that represents the unit rate. The ordered pair that represents the unit rate is always going to be anything that is 1 on the x and then that value for r. So for every 1 step taken, he's going to walk 3 feet. So it'd be 1, 3. That will be your unit rate. This is this formula that you're always going to know. Anytime you see 1 and then the r, that's your unit rate. So we'll work on this some more today. It's what we did in the other part. All right. So let's go ahead and let's go look at the standards and everything we're covering again today. So your I-cans, remember, we're determining if a proportional relationship is proportional by analyzing its graph, what 0, 0 and 1r mean, the connection between 1r and the graph of the proportional relationship and the unit rate. It's what we just practiced this morning. And using graphing tools, that's what we're going to go do in the McGraw-Hill stuff, and clearly explain the characteristics of the graph of a proportional relationship. So we're still working with graphs and we're still working with proportional relationships. By the end of the day, this is what you should be able to do. Just a quick reminder, your vocabulary, we have the proportional. Proportional means that they are The ratios comparing them are equivalent. When I have my table filled out, it's the same ratio for every single one. Non-proportional. Two quantities are non-proportional if the ratios are not equivalent. So if I have different ratios in each table part, or if my line doesn't go through the origin. And then the constant of proportionality is that number that I multiply my units by. So number of steps I took, I would multiply by how many feet in our example today. All right, so let's switch over here and open full screen. So we're going to find the constant of proportionality from graphs. So it says find the constant of proportionality from graphs. When a proportional relationship is graphed, you can determine the constant of proportionality by using the coordinates of any point on the line other than the origin. So we can't use the origin because it's 0, 0, and there is no data there. That means nothing is going on. The constant of proportionality is the ratio of y over x for any point on the line except 0, 0 when x equals 1. So select each point to see the ratio written as y over x when x equals 1 for an ordered pair. So x equals 1 means if I go out 1, that'll always be a thing. So let's look at this first point, if my computer will cooperate. So we have 2, 10. So they wrote y over x, which is 10. How many distance were traveled over 2? How many, what's it say? How much time it took. And then they simplified to 5 over 1. Our next point here, 315. So let's rewrite it. Y are 15, x are 3 over 5, or 5 over 1. It reduced, or simplified. And then 420. Y over x is 20 over 4, or 5 over 1. So this is a proportional relationship because they all have the same ratio, which is what we're looking at. If we look at each point here, just like we were looking at tables, we can get the ratio. Remember, they will always be written as y, your horizontal or your vertical, over x, your horizontal. So, what do you notice about the constant of proportionality and the coordinates a 210 and b 315? So, what did we notice back here? That they simplified. So a is 210 right here, and b is 315. They both simplified to the same thing. Therefore, they are proportional. So let's look at this example. I believe this one uses graphing. Oops, I was all the way at the end because I already looked at it. All right, slide 1. All right, find the constant of proportionality from graphs. In a 100-meter race, assuming the runner's rate is constant, the distance run is proportional to the time spent running. One runner's data is shown. So we're going to find the constant of proportionality. So we probably need our learning tools. As long as it didn't open like 15 of them. Cool. All right, so that is open for us now. So let's go ahead. How are we going to solve this? Well, so select each point to see the coordinates of that point and what that point represents. So 0, 0, that's our origin. After 0 seconds, the runner has traveled 0 meters. Then we have our second point, 5, 31. After 5 seconds, the runner has traveled 31 meters. 10, 62. After 10 seconds, the runner has traveled 62 meters. And then 15, 93. After 15 seconds, the runner has traveled 93 seconds. So we need to find our ratios of y over x, or distance over time, for the given points. So our first point here, we have y over x equals blank over 5. So over 5, which one of these is at 5? So it's going to be 31, which is our y, over our x of 5. So we're going to drag that down. Then y over x equals 62 over what? So which one of these has a y of 62? It's this one right here. We're going to go to 10. So our x is 10. And then our last one is y over x equals what over what? Let's look at our last point. Remember, our y is always first, so 93 over 15. So we're going to put 93 over x of 15. Check answer. Got it. All right. So write the ratios with the denominator of 1 and find the constant of proportionality. So they did the math for us. 31 divided by 5 is 6.2 over 1. 62 divided by 10, well, they had to divide by 5 and then again by 5. 6.2 over 1. 93 over 15 is 6.2 over 1. So each ratio is equivalent to 6.2 over 1. So the constant of proportionality is 6.2. It's that number I would multiply by for how long I run to get how far. So let's describe the constant. Because the constant of proportionality is 6.2, that means that the runner moves at a rate of 6.2, was it seconds per meter or meters per second? Well, we know x was time and y was distance, and we always put y, we have y first in our ratio. So that's going to be our distance, so that would be meters per second. Whatever your y is going to be your first word. Whatever your x is going to be your per, your unit. So based on the constant of proportionality, show how far the runner will travel after 20 seconds. Explain your reasoning. So this is where we're going to need our lovely table here. Okay, so we know that our ratio, our constant of proportionality is 6.2. Maybe. Oh, I remember we have it 6.2 over 1. I want to know how far he runs in 20 seconds. Remember, this number here, your 6.2 here, is your constant. That is the distance that I multiply the number of seconds he ran for. So if I set this up and do 6.2 times 20, when I multiply, remember that 0, everything's 0, so I can just bring it down. 2 times 2 is 4. 2 times 6 is 8. I have 1 decimal point, so he's going to go 84, I think it's meters we used, in 20 seconds. How did I figure that out? How do I know? Well, my reasoning is that if he can run 6.2 meters per 1 second, I multiply that number of meters by 20 to get my answer. All right, at the end of this, there is a check that is assigned for you to complete. Go ahead and do that. This is data for me. It is, even though it has points, it is an ungraded thing in the actual grade book. So get this done. This helps me know what you know.